measurement of structural data. Right. In structural data, there are essentially planar data and linear data, right? And we have covered how to measure this data in field. So coming to the tools that we use in field, first of all, we use compass. Now, can anyone tell which are the two main compasses we use in the field? I mean, measuring compasses.
Brunton compass and clinometer.
Yes, excellent. So Brunton and clinometer compasses. Now these are just not compasses, but they also measure the dip and strike of the planes. We will further discuss how we are measuring there, and we will address some problems there. But let's talk for a moment. Has everyone seen Brunton compass or clinometer compass in real life or in their hands? Anyone? Anybody?
Yes, sir.
Okay. So then I have a question for you. So in general, excuse me. So my screen is visible, right? Hello.
Yes, it's visible.
Okay. Okay. So in general, so see, this is, say for example, this is a normal compass. I'm drawing pretty bad. Let me erase it. So let us assume that this is a normal compass, right? Not clinometer or not Brunton compass. So in that case, there will be north, east, then south, and then west, right? And there will be a magnetic needle that essentially points north to south. Now this is an ordinary compass. But how about a Brunton compass? So if this is a Brunton, or clinometer, so this is north, pretty sure, and this is south. But has anyone noticed that in this kind of compass, we have inverted east and west,
Yes, sir.
right? So this has a needle as well, which will measure the north south, of course, but the east west is inverted. So can anyone say why is that so? Why there is an inverted east and west direction in specifically made for Brunton compass or clinometer compass? Any guess? Anything?
Like when we take readings on in the field, if
Yes.
the on the east side it is 0, then towards the east the reading starts 0, 10, 20, 30. Now if the strike of the body is towards east and you are using a normal compass,
Yes.
the needle would point towards west. It won't give you the actual reading, but if it's opposite, you can get the actual strike direction.
Exactly. Exactly. Very. Thank you very much. You have given a very wonderful answer. So just to express in schematic drawing, say for example, I'm using this ordinary compass, this one, right? So say I have a tree, right? And I have this compass here. Of course, this will be pointing towards north. Now, if this is the north direction, the needle will of course be aligned like this, right? But when I rotate my direction towards this tree, this needle, while it is trying to maintain the direction towards this north, it will rotate further in this direction. So the needle will not essentially follow the direction I am trying to measure. It will rotate in the opposite direction. So opposite rotation of needle. So in that case, we cannot use these ordinary compasses to actually measure the direction of any feature. So if this tree is a feature, we need this needle to be pointed to point towards the feature. So specifically, just because we need to target this feature in Brunton compass or clinometer compass or any geological compass, geological or survey compass, they will have this inverted east west direction, right? So that whenever we are pointing our compass, so say for example, say this is north and we are trying to measure our feature here. So in that case, our needle will point towards the feature, and just because the dial of the compass is rotating in opposite direction, right? So in that case, our north, I mean this dial is moving in this opposite direction. So to maintain that, we have inverted west and east. That means that it will ultimately give us the correct orientation, because the needle or the needle will be pointing towards the feature. So in this case, Brunton or clinometer compass, the needle will point towards the feature. Okay, so this is one of the differences that we encounter while we are using survey compass or geological compass instead of a ordinary compass, because ordinary compass will always tell us where the north is, but the survey compass or this geological compass will always tell us what is the angle between a feature that we are trying to locate and the north or the geographic north direction. So this is the basic difference, right? A geological compass will always tell us the angular difference between a feature and the geographic north direction, whereas an ordinary compass, that will only tell us where the north direction is, and it will not consider the di- angular difference between the geographic north and any feature we are trying to observe. Okay, so this is the basic difference that we observe between these kind of compasses. Now, anybody has any question regarding Branton, I mean the working principle of Branton compass and clinometer compass? Okay, so now let us talk about the structural data that we measure. So structural data measured in the field. So can anyone tell what are the primary structural data that we record in the field?
Strike and dip.
Yes, strike and dip, very much. So strike and dip. But these are planar data, right? That means measured for a plane. However, we also measure two different kinds of data. One is trend and the other one is plunge. And these data are linear data. That means they are measured for a line. Okay. So strike and dip are planar data, and trend and plunge are linear data. Now, what is a strike? So strike, can anyone tell what is a strike is?
So
Uh,
where the vertical and the horizontal plane cuts and the line form is called strike.
Okay, so one answer is that it is, so if I put it like this way, so answer A is the intersection between a horizontal and a vertical plane. Okay, any other answer?
the direction along which feature is occurring.
The direction along which a feature is occurring. Any more answer? Any other answer apart from these two? Anything? Anyone else? Okay. So both of the answers are partially correct. Okay. The definition of strike actually combines these 2 points, of course, but there is something more, right? So how actually, I mean, what is the concept of strike, right? So to understand how this concept of strike has been developed, so let us understand that, say for example, I'm drawing, yeah, people are joining. Okay. Okay. So this is a rocky terrain, whatever, right? Here we have an exposure, an outcrop scale exposure, right? And this is the rock surface. So rock surface 1. Similarly, there is another surface. Okay. So this is another surface, rock surface 2. Okay. Now, a structural geologist who wishes to conduct a field work has, just a second. Okay, a structural geologist who wishes to conduct a field work, he or she has encountered these two rock surfaces. Now the point is they how the geologist could correlate the, I mean, how they could correlate these rock surfaces geometrically, right? So for that they need a data. Now they have, of course, they have encountered this plane, so they would like to measure this plane, right? They would like to measure this plane. But what sort of data that they would take, right? So they are interested to know the orientation of this plane, but how can an orientation of a plane can be measured, right? So to figure out that how the orientation can be made, they created a reference frame, right? So for structural frame of reference, we consider one horizontal plane and one vertical plane, right? Now to measure the strike, we of course need a horizontal plane. We require horizontal plane. Okay, so a quick question, think very carefully. Can a horizontal plane actually have a direction? Think very carefully and answer, because it is important, right? These kind of questions has been asked repeatedly in many interviews for public service sectors like ONGC, GSI, and they also frequently occur in competitive examinations like JAM, GATE, etc. So this is a very important question. Can a horizontal plane actually have a geographic direction? Anybody?
No, because a plane can be oriented in any direction. It is respective to something, it is oriented in a direction.
Exactly. Since we are, so that is the answer. Since the horizontal plane itself is the reference in this case, then definitely the horizontal plane cannot have any direction, right? So horizontal plane is infinitely distributed everywhere in the space, based on which we actually try to measure different orientation of planes. So if this is a plane, so if this is a plane and the horizontal plane is like this, so this is the horizontal plane and this is the, say this is our a rock surface, then these two planes will intersect. Now the intersection line, it will obviously have a direction, it will go like this, right? Because even though the horizontal plane does not have any direction, right, so this plane does not has any direction, but the rock surface definitely, because it is definitely tilted in some direction. So whenever you have to tilt a plane, you obviously have to have a rotation axis of that plane, so that it can orient itself along a certain direction. Now in this case we have of course interested in geographic directions, north, south, east, west, but eventually or mathematically speaking it can be any coordinate, right? So in mathematical terms we actually interested to measure the coordinates, right? So this rock surface, it will of course be tilted, or it will obviously have a direction. Now because of this intersection between this horizontal plane and this inclined plane, we get this line, and this line is called the strike line. So to define a strike line, then we can write is that a strike line is an imaginary line produced by the intersection between a reference horizontal plane and the plane and the rock surface, or any geological or any inclined plane, right? So strike line is an imaginary line produced by the intersection between a reference horizontal plane and the rock surface, essentially having a direction, right? It essentially has to have a direction. This direction is nothing but it is the angular difference between geographic north and the strike line, right? So say for example, this is the geographic north. For example, this is geographic north. Okay. So and this is our strike line. So if we extrapolate our strike line, then we can find this angle. Okay. So this theta, this is the strike amount, right? This is the angular difference between the intersecting line or the strike line and the geographic north direction. Now you have to be careful, or you have to remember that this angle, it is essentially measured on the horizontal plane and not any other plane, because the north is just a direction and we can obviously put that direction on a horizontal plane, and our strike line is already lying on a horizontal plane since it is a intersection between the horizontal plane at the and the rock surface, right? So both of the lines, that means considering the north and the strike line, they both lie on a horizontal plane, and essentially that is why we measured this angle on a horizontal plane, right? So the amount, the strike amount, which is also known as azimuth or bearing, right? We can also say bearing. The strike amount is essentially measured on the horizontal plane, right? Now coming to the deep. First of all, notation of strikes. Okay, there are two common notations. One can say that my strike is, say for example, north 20 east. That would mean if this is north and if this is east, then from north to east, while going from north to east, so if this is my strike line, then this angle would be 20 degree, right? So this is one notation. Another is 0 to 0. That would simply mean for an entire 360-degree area or angular area, if this is north, then from north rotating clockwise, if I move 20 degrees, I will eventually reach my strike line. So in this frame of reference, we have four directions, right? But in this kind of notation, we have only one direction. So in this sense, so say for example, if I say north 180 south, that would essentially mean south. Or say for example, south 180 north, that would essentially mean north, right? And similarly, if I say 0 0 0, that would mean north. 360, that would also mean north. 270, which direction it will be?
West.
West, exactly. 090, it would be east, and 180 would be south, right? So this is the notation. These are the two common notations that we use in the field. We generally follow this one because it is easier to write and it takes less time, whereas following this one following this one would may take some extra time to write and to understand other people what I am trying to say or mean. So generally we use this and this second notation, right? Okay, now coming to deep. So a general definition is the magnitude of tilt or the inclination of a plane, right? However, this definition has to be precise, right? Because in any direction the plane can dip, I mean it can tilt, and for the measurement purpose we can measure the tilt amount or the inclination in several ways. Say for example, in infinite number of ways we can measure it. So that would not actually be geometrically correct if we are trying to uh, properly quantify the disposition, geometric as well as geographic disposition of a rock surface. So for that purpose, so for that purpose, uh, what we do is that we consider a plane, right? Now, of course, we have a horizontal plane. Let us draw it in different color. So this is a horizontal plane. Okay. So this horizontal plane would give us the intersection between the horizontal plane and the vertical plane would, I mean, this inclined plane would produce the strike line, right? So in that case, this strike line may go like this. Okay. So consider this as the strike line. So the deep direction, so talking about deep direction, we always take perpendicular to the strike line as our deep direction. So the plane is actually dipping in this direction such a way that it makes a right angle with the strike direction, right? So this is the true deep direction. So true deep direction will always make 90° with the strike. Is always at right angle with the strike, right? Now, if we project this line on this horizontal surface, so how the projection will be done? It simply will be a vertical line drawn from this deep direction to the horizontal plane, and so this will give us the deep direction, right? So deep direction measured by the compass, because a compass always measures the directions in a horizontal plane, so the deep direction measured by the compass, right? Now what about the deep amount? So remember the definition of strike. We got a definition that it is essentially an intersection between the horizontal plane and a vertical plane, and then I said that of course we need a vertical plane for our reference and a, a horizontal plane. Now in this case we of course need a vertical plane, because other than, I mean, any plane other than a vertical plane, we cannot measure the true inclination on that plane if it is not a vertical plane. So for measuring inclination, we essentially need a vertical plane. Now, if the plane passes like this, uh, okay, so if the plane passes like this, So this intersection, so this angle measured on this vertical plane, this will be the deep amount, phi. Okay. So deep amount is essentially measured on a vertical plane. True deep amount is essentially measured on a vertical plane, which is oriented along a direction perpendicular to the strike. Okay. Now the question is, if I have a plane and if this is the strike line, then perpendicular to that direction, this will be the deep direction or deep, true deep direction. This is the true deep direction. Now what happens if I measure deep along this direction? So if I pass a vertical plane just like this to measure the deep along this direction. So say for example, this is the deep direction and this is the amount we are calling as phi dash. So what is the relation between phi dash and phi? So I am giving several options. A is that phi dash equals to phi. B, phi dash not equals to phi. C, pi dash greater than phi. And D, pi dash less than phi. So amongst these four options, which one will be the correct? Any guess?
Phi dash less than phi.
Yeah, exactly. Phi dash less than phi. This is the correct answer. Why?
It is the apparent depth.
Exactly. So apparent dip is essentially less than the true dip. Pi dash is apparent dip. The definition of apparent dip is the dip amount measured along any other direction apart from the true deep direction. Now the question is, why is it always that apparent deep will be less than true deep? Cannot cannot be can it not be greater than the true deep? Why is it that whenever we measuring the deep along this direction, it is the highest, and any other direction it will be less? Any clue? Any guess? The answer is, I can tell you. Then it can be your extra assignment. You can tell me the answer. I'm just making you just. I'm giving you a hint. Is that if this is the deep I mean the apparent deep amount. So the apparent deep is basically a function of the angle between. So let's just make it. Uh, Say for example this one. So this is let's say this is in general deep. Okay, so this deep, whether it is an apparent deep, whether true deep, anything can it be. So deep is actually the function of the angle between the strike direction and deep direction, right? So this function, it is a trigonometric function. Essentially it is a sine function. Okay, so phi is basically function of sine of, say this is delta, where delta is the angle between strike direction and the deep direction. Okay, now what is the maximum value of sine delta?
One.
Exactly. And when sine delta is 1,
When sine is
90
90,
degree.
delta is 90.
Exactly. Then when delta is 90 degree, that means when the deep direction is perpendicular to the strike direction, right? When the deep direction is perpendicular to the strike direction, the deep amount will be maximum. And that is what we observe here. When the angle is 90 degree, it is the maximum angle or the maximum value of deep. And for true deep, we consider this angle to be 90 degree, right? So that is why the true deep is always the highest deep amount on a plane, right? That is why the true deep is the highest deep amount on a plane. Okay. Now a question: if the angle between deep direction and the strike is delta, deep amount is phi, and so let us make a just a true deep direction, true deep amount is phi, and the apparent deep amount is phi dash. Then find a trigonometric relation between delta, phi, and phi dash. So this is a question. You can note down this question, and in the next class we can discuss it quickly. But till then, it consider this one as an assignment. Okay, you can search in Google as well. If you get the answer, try to understand how the derivation has been done. If you don't, then we will discuss how it is done. But I can give you a hint, is that it involves tan function and sine function. The answers will be in tan of something is equal to tan of something and sine of something, like that. One you already know is that phi dash will be a function of sine delta, right? That I told you. So that part is clear. Then you have to figure out which of these will have the tan and so on, right? So this can be an assignment. You can think this as an assignment and try it yourself. If you are afraid of mathematics, don't be afraid. You can take help from Google. You can simply search this question, and if you have any doubt, we will discuss it in the next class. Okay. So why I'm telling you is this, because if anyone here is an aspires of cracking gate or jam or any other competitive examination, they pretty often introduce these kind of mathematical questions in the numerical answer type section in both the gate and jam examination for geology, as well as other competitive examinations regarding the GSI entrance examination and others. Okay, so this is an important relation they often ask, and if you see the previous year questions, there are several questions that involves this particular trigonometric relation, and it will be helpful for you if you know the relation. Then you can solve easily the MCQ questions. Okay, so this is the deep and strike. Now talking about the notation of deep, right? So apart from strike, deep is like a vector, right? Because a vector has two things. What does a vector have? Can anyone answer?
A quantity and a direction.
Exactly, the vector essentially has a magnitude and a direction. And direction. So for deep, we have deep amount, which is the magnitude part, and we have direction, right? Okay. So deep will essentially we notify deep essentially like this way: 20 degrees southeast, 20 degree words 140. So essentially these are the two notations we generally use, not many more, right? So sorry either mention the quadrant, on which quadrant the, the, the plane is dipping, or just simply mention a direction along which the plane is dipping, right? Now together we dip and strike, therefore we can have then combining notations we generally. So whenever we combine dip and strike, we get attitude or orientation of a plane. Okay, so attitude of a plane would mean simply it has a dip and a strike. What would be the attitude of of a horizontal plane?
It should be zero because it has neither a direction nor dip amount.
Exactly, so we will simply write 0 degree, because Since it is horizontal, it doesn't have any direction, and since it is horizontal, the inclination is zero. So simply write zero, because there is nothing to write about right of direction. Okay. Then say for example I wrote 045 36° southeast. That would mean the strike amount is so. How is this applied? So let us talk about some situation, right? Now we know that true deep direction is perpendicular to the strike direction, right? Okay. So this is the thing we know, that is for sure. Now, in which direction we should take perpendicular, right? So say for example, this is our compass, right? Horizontal plane where we have the directions marked, right? Now I have a plane which has a strike 045, right? 225. So if I join this strike line, in which direction should I take 90°? The question is there. Should I measure the 90° this way, or should I measure the 90° this way? Which is the correct way, right? The convention, therefore, we apply the right hand thumb rule is that if nothing mentioned, So in a way, both the deep directions are correct, right? Right, mathematically both are correct, but if it is not mentioned, if it is not mentioned, then always consider the clockwise direction for getting the deep direction, right? So in this case, if it is not mentioned which is the right direction, I will take this way. Then I would simply consider the plane is dipping along southeast direction, north northwest direction. But in many cases, if a problem is given that specifically mentions that, okay, so you have a strike of 0.45, but you also have a deep direction along northwest. So in that case, there is no question of applying the right hand thumb rule. In this, up to this part, it is only about a right hand rule because I am rotating my right hand, right? So this is like that. So if this is my strike direction, I rotate clockwise like this way. So it would rotate in my clockwise direction, right? So that is why it is a right hand rule, because I will always consider this clockwise angle. If specifically I am saying that if the deep direction is not has been mentioned in the problem, right? If it is mentioned, then of course you have to take that direction, because for a strike line, it has a the strike has two ends, right? It has a 0.45 end and it has a 2.25 end. Now there also comes a question. Now say for example, the deep direction is not mentioned, right? The deep direction is not mentioned. Then possibility one, the given strike is 0.45, and possibility two, the given strike is 2.25. In this case, the deep direction will be along, any guess? Anyone? Which in which direction the plane would dip?
Oh, this southeast.
Exactly, because when the end member of this strike is important. Since it is given 0.45, then you have to add 90 degree from 0.45. In that case, it would be southeast. And whenever it is given as 2.25, then it would mean northwest, right? So observe the strike carefully, right? Which end is given in your data? However, it can also be possible. Now if the data is given, then it can be written as 045 some x degree northwest, 225 some x degree southeast. Okay, anything is possible, or 045 x degree southeast, or 225 x degree northwest. If it is mentioned, then it can be any of the four combinations from these. Okay, now, so this is all of what we talk about the um right hand rule. Now coming to the right hand thumb rule. So simply, so if this is a plane, now if you place your right hand over this plane, right? So if your thumb follows the strike direction, then the rest of the fingers will follow the deep direction, right? So this is how the right hand thumb rule works. So any doubt regarding that?
No, sir. So so in field, if you measure the so in field you place your Branton compass here and you measure the strike direction, right? Now once you have measured the strike direction, you can place your right hand like that, just like that. So this will automatically point towards the strike, right? And you know this direction, then just measure along which direction it is. Your I mean the rest of your fingers, which direction it is pointing. That would be the deep direction, right? So this is how the right hand thumb rule works. Okay, and it is specifically applicable whenever there is a confusion regarding the direction. If it is not mentioned, then by convention you have to use this way, and you have to take the clockwise reading from the strike end you are specifically mentioning. So if it is given 045, then you have to specifically take 90 degree from that end, and if 225 is given, then you have to mention or take 90 degree from other end. Okay, so Moving on to linear features. So linear features are essentially lines which we measure on a plane. Lines will always lie on a plane, right? There cannot be any other source where we can find a line. And geologically, lines are found as lineations, right? So there can be fold axis. This is one of the most prominent lineation that we measure in the field. In the next, upcoming lectures, we will of course learn about fold axis and different measurements of that. But till then, just remember that fold axis is one of the important lineations that we measure. It can be intersection lineation. It can be mineral lineation, and it can be pressure shadow lineation. Sorry, yeah, pressure shadow lineation. So in the fold in this introductory field structural geology course, we have visited to Ghatshila, which is in the Jharkhand district, and there are marvelous structures. Of course, we have gone through the first few lectures. There are of course some exposures on the Ghatshila, and in Ghatshila we have observed all these four kinds of lineations: fold axis, intersection lineation, mineral lineation, as well as pressure shadow lineation. So the in the upcoming sessions we will specifically discuss about these particular types of lineation and how they can tell us about the deformation history of that particular area. In particular, lineations are very much important in understanding the different phases of uh, deformation, whereas planar data, they provide us about the overall structure, whether there is a fold or whether there is a fault. All these kind of major structural things we actually get from the planar data, right? Whereas the linear data, they provide us a brief history. If we can interpret correctly, then we can easily get the brief history of different episodes of deformation that an area has undergone, right? So in Ghatshila, we have seen all these beautiful lineations, right? So once again, I am uh, making it clear that planar data are broadly useful to determine, sorry, the shape of the structure, shape and geometry of the structures, right? Whether it is a fold or fault, right? These kind of things we get from the planar data, right? Whenever we plot the planar data from their their relations, interrelation with them. We can, I guess, get an idea about whether we are seeing a fold or a fault or some things like that. However, linear data are more useful if interpreted correctly. The linear data provide information about different episodes of deformation, right? Okay, so what sort of data we measure? So two common things, one is the trend and the second thing is the plunge. So what is a trend? Trend is similar to deep direction of a plane. It is almost similar to what we know as the deep direction of a plane, right? How come? Now let us consider this is a plane, right? And we have a line. So this is our lineation. Now, as I have mentioned, to measure any azimuthal direction or any bearing, right, we essentially need a horizontal plane. So say for example, this is the horizontal plane we are considering, like that. Okay. And we simply project this line onto this plane like this. So if this is the intersection point of this projection line, we simply draw a line like this. So this is the trend. Trend again, it is measured with respect to the north. So if this is the north, we again measured this angle. Angle between north and the horizontal projection of the line is known as trend, right? And simply, if we pass a vertical plane along that direction, then this angle measured on the vertical plane, the tilt angle or the inclination of the line measured on the vertical plane is the plunge, right? So this is the plunge. So how do we notify, I mean, note these things? So we simply write plunge amount, then put an arrow and trend or the direction, right? So if the plunge amount is say 20 degree, so if I write 20 degree towards 146, that would mean the line is plunging towards southeast. This is the simple interpretation of the trend and plunge that we commonly refer to a line. Now all these data, we have planar data and we have linear data. Then to manage all these data as well as to quantify and to find their geometric relation between all these data, we plot a stereographic projection, right? So I will briefly discuss about the stereographic projection of a plane. So before going to stereographic projection, I would like to ask a question to everyone that uh, do you have any idea about stereographic projection? Any idea? Just to say a few lines.
Yes, sir.
Yeah, what is it?
So, stereographic projection is a 2D representation of a 3D feature, basically. So, in this, there are the great circle, there are the small circle, then there are two types of net. There's equal area net, then there's equal angle net, wolf net, and Smith net. But
Yeah.
in basically, we will use equal area net,
Yes.
and in this, the what we do is basically if a line or a plane, we assume that it's passing through a sphere. So the lower end, the lower end from where it is cutting the sphere, we draw projection towards the center of the sphere or the equator of the sphere, which
Exactly.
is the 2D representation of that 3D feature.
Exactly. Very good. Okay. So assuming that everybody has a little bit of idea about stereographic projection, so to just give you an overview and a sort of recap. So every plane and line, I'm drawing very raw. So every plane and line, yeah, that is. It can be projected on a circle, right? So if this is a sphere, we can project any kind of three-dimensional structure which is present inside this sphere on a two-dimensional plane. So two-dimensional, speaking about a two-dimensional plane, that would generally be a circle. Now, since we are looking in a three-dimensional way, it appears like an ellipse, right? So this is known as the equatorial plane, which is a circle, right? And then we pass a line from the center that essentially divides this entire sphere into two hemispherical parts, right? Now, if there is a plane, right? So a plane may look like this, which is inclined in this way, right? So this is a plane. Now, if we project the plane, now the plane is intersecting with this sphere. Now, if I project all these points, which is lying on this plane in such a way, and then I join it, we might get a circle like this. I mean a segment, an arc like this. So if we see from horizontal point of view, this would be our equatorial circle. Within that circle, we may have an arc. So this arc, they are the same thing. So this arc, it represents 2D representation of a three-dimensional plane. A plane, of course, is a two-dimensional object, but it has a three-dimensional orientation, right? It is oriented in a space. So depending on its angular orientation and inclination, a plane can be in any sort, it can be oriented, it can be placed in any way in a three-dimensional space. In and each of these orientations, they would have separate two-dimensional representation. So this is basically a projection of a plane. So if a plane is lying in three dimension, if a plane is in three dimension and we are projecting that 2D plane in a two-dimensional space, then of course it would give us line, right? So simply think it like that two planes are intersecting. One is horizontal plane and another one is essentially any kind of plane. Just like that, it is the representation of the plane itself which is inclined, and where we are projecting it on the equatorial plane. So equatorial plane is a horizontal plane, right? So that is why the directions that we get here, these two ends, since this plane, this one, it is cutting this horizontal plane in two ends. These two ends are essentially the strike, because strike is nothing but the intersection line between an inclined plane and a horizontal plane, right? So that is why the intersection is giving you this strike line, right? And similarly, the more you have this deep amount, the steeper this arc will get. Now this, say for example, we have a plane like this, right? Then the two-dimensional representation of this plane would be like this, right? Here we can have it like here, like this, right? And eventually, if a plane is perpendicular or vertical, we would have a just the straight line. Sorry, like this. Okay. Now the thing is, the projection of a plane on the equatorial plane is a line. Then the projection of a line will be a point. This is the interesting point. So if we have a line on a plane, so definitely a line would lie on a plane. So again, if this is our uh, sphere and this is our equatorial plane, then, and if this is the line, I mean this central line, the axis, and here we have a plane like this. So consider this as, so we have a plane like this. Okay, and there is a line on this plane. So if we project the plane, if we project the plane, it would definitely give us a circle, I mean arc like this, right? And based on that, whenever we are projecting this line on this plane, this line would plot as a point.